What's going on, y'all? AttorneyTom here. Last night while I was scrolling YouTube, I found a very interesting channel from the U.S. Chemical Safety and Hazard Investigation Board. The USCSB essentially conducts investigations on chemical explosions and other catastrophic events that occur in the United States. And as many of y'all know, I am a catastrophic personal injury lawyer based out of Texas. And you cannot be a catastrophic personal injury lawyer based out of Texas without having cases related to chemical explosions. I'm currently working on multiple refinery explosion cases where victims are either killed or burned head to toe. Unfortunately, it is a frequent occurrence. And speaking of the devil, literally 2 days ago, another refinery exploded in the Houston area, killing at least 2 people and 30 are in the hospital. So I thought it would be interesting for us if we watched the USCSB's investigation of the BP refinery explosion from Texas City. I believe this explosion occurred in 2004, 2005. It was one of the biggest in Texas's history. I think over 10 people died, with hundreds going to the hospital. And quick side note, before we begin, I'm going to try to simplify this process. So I may take some generalized statements that I otherwise wouldn't take in my real job. But let's start with the foundation. Generally, when a refinery explosion happens, there are 2 sides of the spectrum which caused it to happen. On one far end is failure of procedure, meaning the equipment necessarily didn't malfunction, just the people did not do the right thing. On the other side is product defect. So the individuals working at the refinery did everything right, but the equipment failed, and everything in between, because generally it's a little bit of both. And you have the refinery company pointing the fingers at the equipment manufacturers, and you have the equipment manufacturers pointing the finger at the refinery. So without further ado, let's watch the USCSB's investigation of the BP refinery explosion and see if we can identify any issues.
March 23rd, 2005, the BP refinery in Texas City, Texas. Several units at the refinery had been shut down for lengthy maintenance projects, which required nearly 1,000 contractors to be on site, along with BP employees.
So that is actually an interesting fact right away. Depending on the cause of action and what they determined to be the cause of the explosion, being a contractor versus being an employee might affect a victim's ability to bring a lawsuit. If you are an employee, you very well might not be able to bring a lawsuit because you will be barred by workers' comp. And workers' comp is a total scam.
BP had positioned a number of portable trailers close to process units for the use of contractors and other maintenance workers. Over a period of months, BP had located 10 trailers for workers servicing the Ultra Cracker unit, including a double-wide wood-frame trailer that contained 11 offices and was regularly used for meetings. Though these trailers were located near the isomerization unit, the occupants were not warned the ISOM unit was about to start up, a potentially hazardous operation.
Okay, so that right there is potentially negligent mistake number 1. And that is more on the procedural side of the refinery of BP placing this living quarters or operational quarters next to a potentially hazardous site.
At 2:15 a.m. on March 23rd, overnight operators began introducing flammable liquid hydrocarbons, known as raffinate, into a 170-foot tall raffinate splitter tower used to distill and separate gasoline components. Near the base of the tower, there was a single instrument that measured how much liquid was inside. It transmitted this information to both a satellite control room and a central control room located away from the ISOM unit. But this level indicator was not designed to measure liquid above the 9-foot mark. During normal operation, the tower was only supposed to contain about 6½ feet of liquid. But during startups, operators routinely deviated from written procedures and filled the tower above the 9-foot mark, concerned that if the liquid level fluctuated too low, it would cause costly damage to the furnace.
Okay, so issue 2. The tank is never supposed to be filled above 6 feet at startup. However, the operators routinely deviate from that, filling the tank more than 9 feet because they don't want to cause harm to the furnace. This is putting profits over people's safety. They want to make sure that the furnace doesn't get damaged and they don't have to replace it, and they don't care if it causes an explosion. Additionally, BP's own procedures say that they should only fill up this tank to 6 feet, and if they routinely deviate from this, then BP is implicitly okay with it. Remember, it is the company's job to enforce their procedures. So if they routinely deviate from something, the company is giving their approval of it. So it is not an excuse to say, oh, BP's procedures were safe, it was just the operators. If the operators routinely deviate, then BP is okay with it. Issue number 3, potential design defect of this gauge. It only goes up to 9 feet, and if they routinely fill the tank greater than 9 feet, they need to be able to see how much liquid is in the tank. This is not a manufacturing defect because I assume that the gauge is working properly. It just doesn't have enough capacity to accurately gauge anything. So this is more of a design defect. But in reality, I'm not too concerned about this cause of action because if BP wanted to, it's their responsibility to put the appropriate equipment in there. And y'all, I'm just issue spotting every little thing I see. Now, I'm just identifying everything, and then we will narrow it down after we understand what happened.
At 3:09 a.m., as the liquid neared the 8-foot mark, a high-level alarm activated and sounded in the control rooms. But a second high-level alarm, slightly further up the tower, failed to go off.
So now we've identified a potential manufacturing defect in that a warning gauge did not go off. However, other warning gauges were going off, so you could make an argument that this one particular gauge not going off shouldn't have mattered. They should have known anyway.
By 3:30 a.m., the level indicator showed that liquid had filled the bottom 9 feet of the tower and the feed was stopped. The CSB later estimated that the liquid was in fact at a height of 13 feet, but operators could not know the actual level because the indicator only measured up to 9 feet.
Right. Why would they only have an indicator that goes to 9 feet?
The lead operator had been overseeing the startup from a satellite control room within the ISOM unit. At 5 a.m., he briefly updated the night board operator in the central control room about the startup activities. The lead operator then left the refinery early, an hour before the end of the shift.
Issue number 5. The lead operator leaves the plant before his shift ends. Generally, refineries run 24/7 or pretty dang close to it. And when operators leave their shift, they leave detailed instructions and notes for the next operator to come and pick up where they left off. And generally, there is a person-to-person exchange or meeting as they switch off shifts. So there's a full briefing on the status of the plant. So it's a big deal when somebody leaves early and they might not be able to have that briefing.
A new board operator arrived in the control room around 6 a.m. to start his 30th day in a row working a 12-hour shift. He spoke.
Issue number 6, 30 days in a row working a 12-hour shift. Do you think you will be mentally competent or sharp if you worked 30 days in a row for 12 hours?
Briefly with the departing night shift operator and then read the logbook to prepare for the startup. But the logbook did not clearly indicate how much liquid was already in the tower and equipment. And
Issue number 7, unclear logbook about how much liquid was in the tower. So nobody knows how much liquid is in the tower because the operators don't know and they didn't tell one another, and this stupid gauge only goes to 9 feet.
And it left no instructions on routing of the liquid feed and products when the startup resumed.
Issue number 8.
The control board operator only found a one-line logbook entry that said ISOM brought in some RAF to unit to pack RAF with.
Issue
At
number 9,
7:15
too
a.m.,
vague.
the
Nope.
day shift supervisor arrived. Because he was more than an hour late, he received no formal briefing from personnel on the night shift about
Issue number 10, and the last 3 issues have solely been on the refinery personnel side.
conditions in the ISOM unit. At 9:51 a.m., operators resumed the startup. They began recirculating the liquid feed and adding more liquid to the already overfilled tower. As new feed was added, startup procedures called for regulating the liquid level in the tower using the automatic level control valve. But the board operator and others had received conflicting instructions on routing the product. As a result,
Issue number 11, ignoring procedure again.
this critical valve was left closed for several hours, blocking the flow of liquid from the tower. A few minutes later, operators lit burners on the furnace to begin heating up the feed, part of the normal startup process. While the startup was underway, the day supervisor left the refinery on short notice, just before 11 a.m., to attend to a family medical emergency. Contrary to BP's own procedures, no experienced supervisor was assigned to replace him. This
Issue number 12. Y'all, I get it. Family emergency. This guy at that moment had more important things in his life, but it is a refinery with flammable and dangerous chemicals. They left somebody in control who had no experience. And on top of that, they didn't leave this guy with a perfectly running refinery. As we can already see, there are things seriously going wrong at this very moment.
left a single control board operator, now without a qualified supervisor, to run 3 refinery units, including the ISOM unit, which needed close attention. The refinery had eliminated a second board operator position following corporate budget cuts in 1999 after BP acquired Amoco.
Issue number 13. I don't even know. I can't even keep track with how many issues there are. So profits over people, they cut a position because it's going to save them money.
As the startup continued, the tower steadily filled with liquid, reaching a height of 98 feet shortly before noon. More
98 feet, when the normal amount of liquid in that tower is 6 feet.
than 15 times the normal level. But the improperly
15 times.
calibrated level indicator told operators in the control room that the liquid was at 8.4 feet and gradually falling.
Man, this gauge is a disaster. First of all, it's totally incomplete or incompetent. It needs to show more than just 9 feet. And now we're getting into the defect side of it, the product defect side of it. Now it's reporting that there's less than 9 feet when it's filled 95 feet. What a disaster.
Furthermore, the control panel was not configured to clearly warn operators of the growing danger. It did not display flows into and out of the tower on the same screen, nor did it
Issue number 15, BP doesn't provide their refinery with correct information or useful information.
calculate the total liquid in the tower. Meanwhile, the maintenance contractors, who were not involved in the operation of the ISOM unit, left their work trailers to attend a company lunch, celebrating a month without a lost time injury.
The irony. Let's listen to this again.
Maintenance contractors, who were not involved in the operation of the ISOM unit, left their work trailers to attend a company lunch, celebrating a month without a lost time injury. At 12:41 p.m., an alarm activated as the rising liquid compressed the gases remaining in the top of the tower. Unable to understand the source of the high pressure, operators opened a manual chain valve to vent gases to the unit's emergency relief system, a 1950s-era blowdown drum that vented vapor directly into the atmosphere. Operators also turned off 2
I just want to point something out, and this is a big issue, and they haven't necessarily addressed it here, but it is an issue. A lot of these refineries in Texas were built in the 30s, 40s, 50s, and 60s, and they really have not been updated since then, because updating these refineries is very, very, very expensive. So a lot of these refineries operate with outdated equipment or methods or infrastructure because the refineries are just old, and they wouldn't want to spend hundreds of millions or billions of dollars building a new refinery when they have one that they can just constantly patch together.
Vented vapor directly into the atmosphere. Operators also turned off 2 burners in the furnace to lower the temperature inside the tower, believing this would reduce the pressure. Nobody knew the tower was dangerously full. The operators did become concerned about the lack of flow out of the tower and began opening the valve to send liquid from the bottom of the tower to storage tanks. But this liquid was very hot. As it flowed through the heat exchanger, it suddenly raised the temperature of the liquid entering high up the tower by 141 degrees Fahrenheit. It was now about 1 p.m. Contract workers, unaware of the startup and the looming danger, returned from lunch and began a meeting in the double-wide trailer.
So this was issue number 1, the location of this trailer being parked or located so close to a potentially hazardous zone.
In the corner room, closest to the blowdown drum. Over the next few minutes, the hot feed entering the tower caused the liquid inside to start to boil and swell. Liquid filled the tower completely and began spilling into the overhead vapor line, exerting great pressure on the emergency relief valves 150 feet below. At 1:14 p.m., the 3 emergency valves opened, sending nearly 52,000 gallons of flammable liquid to the blowdown drum at the other end of the ISOM unit. Liquid rose inside the blowdown drum and overflowed into a process sewer, setting off alarms in the control room. But the high-level alarm on the blowdown drum
This is going to turn into vapor.
None of the operators knew of the catastrophe unfolding in the ISOM unit. As flammable hydrocarbons overfilled the blowdown drum, operators nearby saw a geyser of liquid and vapor erupt from the top of the stack. The equivalent of nearly a tanker truck full of hot gasoline fell to the ground and began forming a huge flammable vapor cloud.
So now we're in the danger zone, right? When there is a vapor cloud of a flammable chemical, literally anything can spark that cloud, and the entire thing goes up in flames.
Vapor cloud expanded in just 90 seconds, engulfing the unit and the nearby trailers full of workers. About 25 feet from the base of the blowdown drum, 2 workers were parked in a pickup truck with the engine idling. As flammable vapor entered the air intake, the diesel engine began to race. The 2 workers fled, unable to shut off the engine. Moments later, witnesses saw the truck backfire and ignite the vapor cloud. Powerful explosions swept through the area. The blast pressure wave accelerated through the ISOM unit, causing heavy destruction and igniting fires. The workers inside the trailers were right in the path of the explosions. The fires continued to burn for hours. 12 of the 20 occupants of the double-wide trailer were killed, along with 3 workers in a trailer nearby. 180 workers were injured, many with serious burns, fractures, or other traumatic injuries. The wood and metal frame trailers were blown apart by the blasts. Firefighters struggled to rescue the injured and recover the victims. 50 large chemical storage tanks were damaged, and the ISOM unit remained shut down for more than 2 years. The disaster at BP Texas City was the most serious refinery accident ever investigated by the CSB.
Wow, that was really sad. But on the spectrum of refinery explosions, this clearly leans on the side of procedural mistake. this was BP's fault. I'm not really too concerned about any potential products liability in this case. Yeah, that gauge could have worked better, but it was probably the wrong gauge to begin with. BP probably needed a gauge that showed much more than 9 feet in that drum. Additionally, they could have manufactured their data flow to show how much was in the tower, and they failed to do that. On top of that, so many operational mistakes. It is foreseeable that when you are in a refinery, something goes wrong. So why would you put living or working quarters right next to the potentially hazardous area? Additionally, so many operators either left early, didn't leave complete notes, weren't fully aware or qualified to be running the position that they were in, and it all culminated in a disaster. What I find very interesting is the USCSB presents all this information in a great, clean fashion, and they can do that because these reports generally come out years after an explosion happens. When they do happen, in order to find out all this information, it is very, very labor intensive. And that is what we as lawyers have to participate in as well. When we are representing hurt clients, we have to hire experts to get down to this. And there's a lot of finger pointing because nobody wants to take responsibility, because why would you? You know that the liabilities are huge, and it's human instinct to just want to blame another party. I'm sure at some level, BP's stance or excuse was, well, if that gauge that only showed 9 feet wouldn't have read 8.4, we would have known that there was at least 9 feet of liquid in the system, and we would have taken appropriate action, even though they probably wouldn't have, which is ridiculous to think about because, as they told us, the operators routinely started this process above the 9-foot threshold to save the furnace because they didn't want to damage the furnace. Additionally, their safety procedures said that it is startup protocol to use the automatic level control valve right here, which they did not use because the operators received conflicting messages, probably because no experienced operator was on site. And the control panel didn't accurately tell them what was or was happening inside of the drum. And I cannot get over the lack of operational capacity at the refinery at the time of the explosion. Nobody was experienced there. The people who were experienced left early. They didn't write full and complete briefs to notify the people who are starting the next shift. And if the people starting the next shift have no idea what they're doing, the very least you can do is give them a full comprehensive report. So at least they have a prayer of not blowing everybody up. Again, this was from 2004, 2005. Very tragic, very sad. I hope you learned something. This is what we do for a living as a catastrophic personal injury lawyer. Yes, today's video was clearly oversimplified. So if there are any chemical engineers or refinery experts in the comments, please don't roast me. I'm just trying to engage or show y'all what I do. I thought it was an interesting video for the purposes of an educational experience. All right, y'all, thank you so much for watching. Make sure you hit that like button and consider subscribing to the channel. We cover a wide variety of videos. Literally yesterday, I did a fast food tier list. So we are going in a lot of different directions, but we're having fun, and I hope this video was worthy of your time. Thanks for watching. Bye.